Welcome to David Academy. So today I'm going to solve a question which is assigned to me in a special assignment by Mr. Alvin. So here's the question. A 15 feet ladder is leaning against a wall in a garden when its base starts to slide away. By the time the base is 10 feet from the wall, the base is moving at a rate of 6 feet per second. How fast is the top of the ladder sliding down the wall? Okay, so now I'm going to write out the information that I get from this question. So firstly, I would draw a graph which represent the condition in the graph. So it would be there's a wall. And I'll put this so it look like a base for it, and then so here's the ladder. So we have 15 feet ladder leaning against a wall in a garden. So this one would be 15, and then I'm going to put this as y and this as x over here. So now, and it's the question says that when the base is moving when the base is 10 feet from the wall, which means like the condition would be this would be 10. And then the base is moving at the rate of 6 feet, so the dx dt is provided. Its dx dt is 6. So now I have get what I want. In any problem solving or when I'm solving any types of questions in math, make sure you list out all the informations that you need to make sure the markers won't be confused with what are you doing over there. So firstly, this is basically a differentiation question. So now I have this information right here, which I would make an inference. This will lead this problem could be solved by using chain rule. So I assume it look like this. The reason why I put dy dt is the question asks that how fast is the top of the ladder this way sliding down the wall. So it's asking the speed, so it would be dy dt. So using chain rule, it's dy dx times dx dt, which dx dt is provided. So this is our first step. We draw out the graph, we list out the information, and we put the theorem that we are going to use, which is chain rule. So it's actually chain rule. So after that, as what we know, we have to determine what equation to be used. So since we have a right triangle over there, and we could get our equation by using the Pythagoras theorem, which is basically your a square plus b square, which is your which is going to equal to c square. I'm going to draw it out over here. It's actually so if this is a, this is b, and this is c, this actually is Pythagoras theorem, which is a square plus b square equals to c square. So from this information, we can determine that the equation should be x square plus y square equals to 15 square. So right from here, we could use this equation to find out the dy dx. So dy dx, which means that we use this equation to find out dy dx, and since this one is provided over here, So it leads us to back to the dy dt, which we need to find to solve the problem. So let me get started with the equation. Firstly we kind of rearrange the equation and make it to become y square equals to 15 square minus x square, and then make it become this way. So we have the equation right now. So once we get the equation, since we have y over here, we have x over here, and then straight away we know that we can do dy dx. So, but right before that, to make things simpler, I would do this. We just not remove, but change the square root into power 1 over 2. So it's easier for us to differentiate. Okay, the next thing is we straight away do the differentiation. And then, okay, so firstly we put n over in front of the bracket, and then we write things again. So 1 over 2 minus 1 is negative 1 over 2. So do take note that we have to rewrite the what's inside the bracket and differentiate them. So from here, because this is a real number, it's actually not it's actually 0 after you differentiate, and then we have to write this out over here, which become minus 2x. Okay, so just now we have x equals to 10 over here, so we can straight away substitute into here. Okay, I'll do it out. So 1 over 2, okay, so 15 square minus 10 square, and then we label this over here, and then minus 2 times 10 over here. Okay, so after that we could kind of simplify them by using calculator, because it's all numbers inside, there's no more unknowns inside. So okay, I'll write it again quickly. So dy dx would become, okay, I kind of do it out so it won't be confusing. Okay, so what's left is minus 20, and then using calculator. Okay, so by using calculator we could straight away type 1 over 2 times inside should be 125. The power is negative 1 over 2. So negative 1 over 2. Okay, wait for a while. I'm almost done. And then times minus 20. Okay, what we get is minus 0.8. Okay, 944. Okay, so now we have our dy dx. So dy dx, oh sorry, it should be dy dt. So make sure you recheck every steps when you are doing math, so that you won't lose any marks over here. So it should be dy dt equals to dy dx times 6, which is provided, and then we put in minus 0.8944 times 6, and we are going to get okay, let me count. 8944 times 6 equals to minus 5.3664. I'm going to use 4-digit decimal place, so it would be more accurate. So this is our answer for the dy dt, and then we have to answer it out. Okay, because this one is actually shown in negative velocity. It's negative velocity. So because it's asking that how fast is the top of the ladder sliding down the wall. So we should change it by modulus it into speed. So we put modulus over here and then change it into 5, okay wait, 5.3664, and then it's feet per second. Okay, so the answer of this question, which is how fast is the top of the ladder sliding down the wall, the answer is d by dt equals to 5.3664 feet per second. So usually we will get all, because this question is 5 marks and we can already get all marks for it. Okay, we list out this and then the workings, and then we differentiate and we sub in, and then we bring the things that we got over here into the chain rule. So I think yeah, we have all the marks over here. So it's actually quite simple, and I heard someone actually use the dy dt straight away, which is like in terms of t, and that is also okay, but this one is an easier way to do it. So I hope Mr. Alvin and others could really enjoy this video. It's my first video. I'm kind of shy, but it's okay. So have a nice day, and today is Thursday, so happy Thursday. Thank you, and hope everyone can do well in their finals for fall 2016. Thanks.